Describe fully a single transformation that maps triangle ABC onto triangle LMN. Now, we know that this is an extension of our previous problem. In the previous problem, this triangle, which is the resulting triangle, or the image of this triangle, was obtained by reflecting this triangle in the x-axis, then in the y-axis. That is important because we know that in transformations, if we reflect an object in two mirror lines and the mirror lines are not parallel, then the resulting object will be a rotation of the original. So we know that. Therefore, we are already sure that what we have there is a rotation. However, if we did not have that information, we could still tell that it is a rotation because they have the same orientation. Meaning that if we take a look at A and we go ABC, A, B, C, we go in a circular fashion like that. A, B, C, A, B, C. That is a clockwise motion. And if we do the same L, M, N here, L, M, N, L, M, N, L, M, N. That is also a clockwise rotation. Those being clockwise rotations will tell us that the transformation is a rotation. Why? Because size transformation have the same orientation, but the objects will be of different sizes. So because there is no change in size, then we are sure that it is not a size transformation. If it were a translation, then we know that the objects would just be exactly alike, with just the location appearing different. So for a translation, we will have the objects looking exactly alike at different locations. So we are sure that it is not a translation. So we are sure, because the orientations are the same, that what we have there is a rotation. And then we may go straight ahead and find the angle and direction of turn. However, on this occasion, we are not led into this blindly, or we shouldn't, because we should be educated that the double reflection in lines that are not parallel will result in a rotation. Triangle ABC was reflected twice to its image LMN, and the mirror lines, the x and y axes, are not parallel. The single transformation is therefore a rotation. So we are sure that it is a rotation. In order to describe a rotation for the CXC examiners, candidates are required to state 1. The angle of rotation, 2. The direction of turn, clockwise or anti-clockwise, or we may say clockwise or counterclockwise. And also we need to state the center of rotation. The center of rotation is the one that we will attempt to determine first. And the order does not matter in which you determine first. For rotation, that is the result of reflections in non-parallel lines. The center is located at the point of intersection of the two mirror lines. So we have two reflections in the x-axis, in the y-axis. The center of rotation will be located at the point of intersection of those two axes, which is right there. And the center of rotation is therefore located at the origin, whose coordinates are 0, 0. So we know the coordinates of the origin. Or we may just say the origin. What else do we need to mention? The angle of rotation. So how do we find the angle of rotation? Well, it's easy. Connect the point A to the origin, which is the center of rotation. Connect any point to the center of rotation. What will we do next? Connect the image of that point to the center of rotation. So connect the point L, the image of A, to the center of rotation. So we'll have to make use of a point and its image in this exercise. The point is connected to the center of rotation by a line segment, and we do the same for the image of that same point. It is clear that the two joining line segments form a straight line, which gives a 180 degrees angle. We have here a straight line, and of course there's no getting around it. Everyone knows that a straight line or angle on a straight line is 180 degrees. Therefore, our angle 180 degrees is our angle of rotation. What about the direction of turn? Since 180 degrees is half of a revolution, we need not include the direction of turn, because half of a revolution in any direction will take us to the same point. So it does not matter whether it is clockwise or counterclockwise, because if we go 180 degrees clockwise, we will end right there, and if we go 180 degrees anti-clockwise, it will end at the same point. So we don't need to mention that for a 180 degrees angle of rotation. So there we have our 180 degrees angle of rotation. So let us verify that 180 degrees rotation will actually result in the triangle LMN. So let us verify that 180 degrees angle of rotation will take triangle ABC all the way around to its image LMN. Rotate triangle ABC through 180 degrees about the origin. If the result is triangle LMN, then we know that our propositions are correct so far. We don't have to do it, but we are just doing that now for verification. And we have the triangle ABC being rotated through 180 degrees. And let us see what will happen. It fits exactly onto triangle LMN. There we go again. Rotating triangle ABC by 180 degrees about the origin, and we keep going around, and let's see what will happen in the end. It fits exactly on triangle LMN. We are therefore sure that our proposition is 100% accurate. The resulting triangle is an exact fit. We may proceed to put all of the components together and give a full description of the transformation. The transformation is a rotation, putting all of the components together. The transformation is a rotation through 180 degrees that is centered at the origin. And we do not need to give the direction of turn, because 180 degrees in any direction will result in us ending at the same point. Remember that for a 180 degrees angle of rotation, we do not need to give a direction, as any direction will give the same result. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.